All right, Algebra 3, hope you're doing well today. This is Coach Johnson. We're looking at trying to prepare for the test on block day. This time is from 7:15 to 8. There may be some students that come in, ask questions, to kind of make it a free-for-all. Any help I could be to help you out in that way. To kind of intro this, I want to make sure I touch base on a couple things. First off, the formula sheet that we will use on the test is online. It'll be right underneath the alumni picture. It's kind of right there on campus from 4.1 to 4.4. You can also access that in class. Take a picture of that for tomorrow. A couple things you need to know. First off, you need to know SOHCAHTOA. That will not be on there. So SOHCAHTOA is the first thing. And then the other thing that's kind of not going to be on there is the sines with y, cosines with x, tangents y over x, and then the reciprocals of those with secant, cosecant, and cotangent. So you might want to look at those when we're talking about the unit circle. When I say what is sine of 30 degrees, knowing that it's related with y, that's something too you're going to need to know. So those two things are just some things that just to kind of get down as you prepare for the test. I will mention that in class, but I want to make sure I put it on here as well. Something else I want to make sure I mention. This is not on. Let me make sure. This one is not on campus. Okay, this is not on campus because I don't want to confuse anybody. But what we're going to do is I'm going to push that. There we go. This right here is the extra problems that will be on the test. I wanted to get a little bit more practice on this. So that right here, you'll see 37 to 44. This is an extra section in class. The ones that you have are right above it. You have all those there. But this one right here, make sure you get those done. If you don't turn those in with the review, I'll still give you credit on that because that's partially my fault there. But in order to prepare for the test, which is the #1 priority, you need to make sure you know how to do these as well. All right? Perfect. All right, so we're going to hop right straight into this today, and we'll post this online, and we'll kind of go from there. All right, so right now I've got some students that are in here, and we're going to get us started. Again, some may come in, and that's absolutely fine, and we will go from there. All right, sounds good. All right, we're underway. Let's do this. I'm just going to kind of open it up for questions. Anybody in here that's watching the podcast or with me live, you could throw questions out there, and we'll rock and roll on that. So if you could give us just 30 seconds, we'll set up. And we'll throw out questions for us. All right. Hey, y'all, real quick, because I'm podcasting right now. Right on the back table, there's extra problems right here. Okay. I would get those out, and I can address those questions as well. All right. So we're just going to do again questions. Any questions that you want there, we'll go from there. Fly, did you have one? All right, we're going to do 2 and 5 here, and I'm going to highlight these as we go so that we can kind of address those and put those on there. Again, I tell you, the review is pretty good as far as the test is concerned. If you know the review, you're prepared for the test. So just kind of a heads up there. All right, so this one says, #2, says find a coterminal angle with 526 degrees. That is between, that's positive, okay? It's got to be positive coterminal, and it's between 0 and 360, okay? Is that what it says there? Yeah, angle less than 360. Say it again, I'm sorry. 528. Oh, is it 528? My fault. Awesome. All right, so because of the 528, remember coterminal means that wherever I start, whatever angle I'm at, I could find another angle by either adding or subtracting 360. Okay, if you can envision this at home, if you're watching this podcast, if you can envision me when I rotated around, jumped around 360 degrees and landed right where I started, that's what we called coterminal. So what could we do, and anybody can answer this, what could we do with 528 to find a coterminal between 0 and 360? Yeah, let's subtract 360, okay? So when I do that, when I subtract 360, I'm going to end up getting something that's between 0 360. So what would that equal? We could get our calculators up. What's that again? 168. That sounds right. Yeah, 168 degrees would be the answer there. Okay, and that's what we would use. Now, 360 is with degrees, right? We know that. But if we were talking in terms of radians, the same thing would be true if we added or subtracted 2 pi. So just kind of keep that heads up. That's where we use the common denominator and kind of go forward on that. Another note is if I said find a negative value, I might have to subtract 360 again to find a negative value to go with that positive. Okay? Great question. I would tell you exactly, I would tell you that. Hey, give me a positive and give me a negative. So again, I'm not going to have you guess on that. This one says that we want to find a positive one between 0 and 360. And so that's kind of where we're moving with that. All right? So again, that was number 2. All right, let's look at number 5. Number 5 is another good one. I'll be honest, number 5 is will be on the test. Okay, it will be. And I think we did this one in class yesterday, but this is good to have on the podcast. S over R equals theta. Now, we know what is S again? Yeah, S is arc length. Good. What is R? 15.2. Good, because that was what was given to us. Perfect. And as far as theta goes, theta is our degrees, right, in radians. And when I think of theta, we look at it, and a lot of people in class put the 250 degrees. Okay, that's what they put. But what's the problem with that? Why can't I plug that in for theta? Oh, well, this isn't in radians. 15.2 is just a value, right? But as far as theta, in order to plug it in, you're right, though, Ian. We got to make sure that it is in radian form. So we're going to multiply this by what to get in radian form? Good, pi over 180. All right? Is anyone in here confused on that? Does that make sense? Okay. Can I reduce 250 and 180 down? Yeah, zeros. I like that. Good, Carson. So now I've got 25 pi over 18. So what we could do now is instead of theta, we put 25 pi over 18. And what we could do now is we kind of put it this way. We could say S over R, S over 15.2, my fault, equals 25 pi over 18. Okay? Is there any way we could get rid of that 15.2 here? Yeah, multiply by 15.2. Good. So then we could do it just across, right? 15.2 times 25 pi. And then I could divide that by 18. And when I do that, I think I get approximately 66.3. And that would be sufficient. You could just round it to that first decimal there. Say that again. So right here, do you see that how this is S over R? I'm trying to get S by itself, so I multiply by 15.2 both sides. And then I just multiply across and then divide by the bottom. So 15.2 times 25 pi, and then I'm going to divide that by 18. All right. If you're at home, a lot of people, for some reason, they get confused. They like cross multiply divide. That's not right. Okay. Multiply cross and then divide by whatever's on bottom, and you'll be fine. Okay. Questions on that one? Awesome. All right. Keep us going. Do we have another one at all? 11. All right. I like that one. The key's wrong.
It might be.
All right, we'll take a look at it. Does anyone know the identity for that one with cosecant and cotangent? Remember on 11 says, for those of you at home there, okay, and those of you in Sweden who watch me on a regular basis. Yeah, okay, so, wow, yeah, this one's a little different, isn't it? Yeah, you kind of, because they're not the same. Did I say that was equal to 1 on the answer key? I think I might have said that. I don't remember on that. On this one, I will tell you that since the pi over 2 and pi over 6 are different, we can't solve it. Okay, we're not able to solve it. Now, as far as the test goes, I'm not sure if there's one like this on the test. I'm not sure. I don't think there is, but I don't want to deceive you on that. One thing we want to do, though, is just in case, this is just good practice, is how do I find what cosecant of pi over 2 is? Well, the point at pi over 2 would be 0, 1, right? And the point at pi over 6 would be square root of 3 over 2, comma 1/2. Now, why is that important? Well, in this case, what we can do is when I do the cosecant of pi over 2, I know cosecant's related with sine. It's the reciprocal of sine. So that means that I take 1 and I put 1 over 1, which would just be the same thing, right? Does that make sense? Are you with me so far? So this would be 1. Now, here's the thing. Because it's squared, we're going to bring that squared down, and we're going to know that it's 1 squared. Okay? Now, we know that that would be 1. We know that. But, again, we've got that left side kind of complete there. Now, cotangent, what would be the ratio for cotangent? This was something that I said at the beginning we need to know. It's x over y, right? If tangent's y over x, cotangent's x over y. So I'm going to take this x and put it over y there. So this would be like square root of 3 over 2 all over 1/2. So I'm going to flip this to the top and multiply by 2 over 1. Cancel, cancel. So what's the cotangent of pi over 6? Root 3. Okay? Have I blown anyone's mind so far? Say again. Always? Hey, that's my job. So we could take square root of 3. And what happens with the squared again? Yep, we're going to bring it down and we're going to square it. So what's the square root of 3 squared? 3. Good. And then at that point, it's 1 minus 3, which would be -2. Good. -2. All right. Is that what I got there on the key, Carson? Yeah, but it's a different way. Did I do it a different way? Maybe. A little bit? Okay, I can take a look at that later and make sure, and maybe go forward with you on that. Now, let's talk over this real quick. I think, does anyone have that identity again? The cosec, the Pythagorean identity? That's true, they come from that, but that's these identities where it's like sine squared plus cosine squared equals 1.
Oh, I got them right here.
Yeah, what on that, Ian, could you tell me, is the cosecant and cotangent, do they go together?
Yeah.
They do, right?
It's 1 plus cotangent squared x equals cosecant squared x. So you minus the squared x.
Yeah, so I got a question for y'all. What if I said this? What if I said cosecant squared of pi over 6 minus cotangent squared pi over 6? What would that be equal to? Well, this is the identity. Does everyone understand that? Okay, this is the problem. This is the identity. Is theta the same or is x the same in the problem?
Yes.
It is, right?
Yes.
So what could I do in order to get this identity to kind of match up to this? I could subtract this, right? And when I do, what would this be equal to then? That'd be equal to 1. Okay? Does that make sense? That makes sense? Look on number 10. We did that one in class, right? We did that one in class. That's pretty much the identity. What would that be equal to? 1, exactly. Okay? Are we good on that? All right, so just check out the identities. I'm going to give those to you, but I want to make sure that you at least have that information there. Okay. Do you all have any other questions as you look at those there? We're just going to keep rocking.
27. Anyone from 27 to 32.
27 to 32. Oh, yeah. So this is great. 27 to 32, you could cross off. Okay. 33 to 36, I said you didn't have to do either. But reality is that you should be able to know how to get that answer, right? What would you do for one like 33 for your calculator? What for the number 33?
Yeah.
Actually, this one is not even. It's actually easier than that. All we're going to do is plug it into our calculator. Now, what mode would we be in? We're going to be in degrees because we're trying to get degrees out here. Okay, we're trying to get degrees out. And so we're going to plug in and we're going to get that out going forward. Okay. 32. Yeah, 27 to 32. Okay. Yeah, you're good right now. We're going to do that. We'll do that later. We're not there yet. Okay. So 27 to 32 cross off. As far as the inverse goes, the sine inverse, tan inverse, cosine inverse, all those. And I'll check on the test. I don't know if that will even be on the test, but I can check. So ask me in class about 33 to 36. But again, that's just a calculator one. We should be good on that.
Will there be a calculator and a no calculator section?
I believe from what we've used, we'll have I think it's all calculator. Now, here's the issue. If you go to numbers on the front page, numbers 17 to 26, it says no calculator. The reason why is because if you put in your calculator cosecant of pi over 3, you may get a correct answer because it may end up being like 1 or something like that, 1/2, whatever. But the problem is that there's some of these that are like square root of 3 over 2, square root of 2 over 2, and if you give me a decimal, I can't give you any credit on that. From 17 to 26, the application there is you're using the unit circle to solve for that. Does that make sense? Okay, so just be careful on that. That's something too that we want to be just leery on. Okay. Could I do one as well? Let's do number 20. Can we do number 20? The reason why is I want to change that problem around a little bit. We're gonna on your sheet there. You could keep it the same, but on number 20, I like for us to do this cotangent of negative 150. I believe when I saw on the test there was one with a negative value. Now don't get freaked out about that. We're still doing the same exact thing. The only difference is on the answer or on the review, when it's positive, we go in the positive direction. Correct? 20? Usually we'd stop here, do this is xy. Remember cotangent's x over y. We divide that out and we're good. But the problem is now we have negative. If it's a negative value, we've got to go backwards. So we're going to go to the negative 150, which should be about, it's the same distance. It's just going backwards, and now it's in the third quadrant. Okay? So where would that fall? It wouldn't be 150. What would that fall at?
No, 215, right?
Not quite.
225.
Not quite. You could do 150 or 360 minus 150. You'll have a whole unit circle.
210.
Is it 210? I think it's 210. 210 there. Is there anyone that doesn't understand that? Where that's at? Is everyone good on that one? Okay, so do you understand like this right here, even though it goes negative 150, we're really looking at the 210-degree value.
And even though it says no calculator, you can do that.
Yes,
Okay.
yes. You'll have your calculator to do that. What I'm saying is
You can't enter that.
please don't, because you're going to get it wrong. Okay, if you do. Now, there'll be a couple where it says use a calculator to give me a value. That's different. But with the no calculator, what that means is you'll have a calculator, but don't use it, because when it says use the unit circle, you have to have an exact value, because I'll know whether you did or not. That makes sense. So at 210 degrees, we know that this value, check me on it, should be negative square root of 3 over 2, negative 1/2. Okay? Now, like I said earlier, those of you who just came in, I just want to make sure I address this too. You can go back and watch this video and kind of hear me again. But this over here, like the fact that sines with y, cosines with x, tangents y over x, and then you have your reciprocals, you'll need to know that, okay? So that's not on the formula sheet. It's one of the few things that's not, but that's one of those things. So when I do cotangent, we know tangent's y over x, therefore cotangent is x over y. Good. So I could just know that it's the x, which is negative square root of 3 over 2, over the y, which is negative 1/2. Okay? So what I'm going to do is I'm going to flip it to the top, multiply by the reciprocal, which is negative 2 over 1. Cancel, right? And my value will end up being what? Positive root 3. Excellent. Very good. Say that again.
I said you saw number.
Did I?
Yeah, you saw 23.
Oh, 23. Yeah. So if you look at 23, okay, this is big time. What is 210 degrees and negative 150 have in common? Let me say that again. There you go. 210 and negative 150 are coterminal because they're what? 360 degrees apart. Very good. Okay. All right. Did that blow anybody's mind what I just did? That just did? How so? How can I help, Carson?
No, it's just wow.
Yo, you know it now. No, that's perfect. That's good.
Why is it positive root 3? Why would it be negative?
Great question. I've got two negatives down here. So a negative over a negative is a positive. Also, Morgan, here's something too. If you ever forget, okay, just when I go through and check, so for me, this is how I take a test. I go through and I take it as quick as I can. And then I go back through and I say, okay, does this answer make sense to this problem? So like, for instance, if I know I'm in the third quadrant and you drew the picture, okay, and I know that this is all students take calculus, I should know that when I'm talking about tangent or cotangent, that it should end up being positive value in my third quadrant eventually, right?
Yeah.
Now here's something that you can maybe think on. If it was a positive, let's say this was a positive here, what would be my value?
What do you mean?
So if I did cotangent of positive 150 and I did x over y, what would be my answer to that?
But when you have to find the
Same thing. That'd be-
Good.
That'd be negative.
Correct. It would be the same thing. It'd be root 3. The only difference is that it would be negative.
oh, okay. I just didn't figure out.
That might have been a bad question, but does that make sense though, what we're looking at? So it's just kind of, I'm putting a lot of things together. Now, that problem, all it asked for was 150, okay? What I'm trying to do is give you some problems that I know are on the test, and one of them is that it will be negative. So just make sure you kind of identify that for that one there, okay? All right, go ahead, E.
What is the unit circle thing for the bottom of the back page?
Okay, so on the test, I am going to I'm going to have you do one. So the first thing you're going to do is you're going to come in, and I'm going to require you to know one quadrant. Okay. I'm not going to tell you what quadrant that is, but I'm only going to have you have one. The reason why I'm doing that is just to keep you accountable for knowing it. Now, y'all did a great job on that last time, so I look at it really as an opportunity to gain points. Really, gain points, kind of to get your grade up, so that when you get to this. The second part, I'm going to give you a full unit circle that's already filled out for you. So you only need to do one quadrant. So that's the first thing you do. And then afterwards, you're going to have a formula sheet with all the formulas other than SOHCAHTOA and other than the YX and Y over X stuff. Those are the only two things that will not be on there. Okay? And in class, and I can get those to you later, ladies. Back in the back, I have the formula sheet you have. You can take a picture so you have it. It's also on campus there too. Okay?
Can you just real quick write out the five?
Yeah, so
Which ones are we not
Great.
gonna have? I'm sorry.
yeah, so first thing, it's really our ratios, like the ratios we learn. It's really things that it's universal that we should know. So for instance, we know the SO sine is opposite over hypotenuse there. Ca, adjacent over hypotenuse is cosine. And TOA, which is opposite over adjacent, right? We also know that cosecant would be the
Opposite.
yeah, the opposite of that. Now, here's the thing on the formula sheet. I give you this. So I say sine is 1 over cosecant. I give you that.
Okay.
So you already know that they're reciprocals of each other. You just need to remember that, oh yeah, cosecant, it applies to this too, right? So secant, reciprocal of cosine, and cotangent's reciprocal of tangent, okay? And then the last thing, and again, this is just, again, I say universal, you just need to know this. Sine, cosine, tangent, same thing. So sine is related with y on the unit circle. Cosine is related with x. Tangent's y over x. That's really all right there. Now, I'll tell you that on the formula sheet that I gave you, I did not give this, s over r equals theta, but I will on the test. I don't mind that. I can give that to you on the test. But I think that that's all that you really need there. All that you need there.
And cotangent for the
Correct. So cotangent's x over y. Also, you need to know that cosecant would be 1 over y, and secant would be 1 over x, right? It's just the reciprocal of them. And we've done that a million times. I feel like the last week and a half. So we should be okay with those. I feel pretty confident on those there. All right. Another thing too, and I've said it kind of a couple times, and I'll give this to you, is there were the problems of 4.4 I did not get to you. So that was what MML was over. Okay. I just added a few problems. You can use these for your just reviewing. You don't have to turn that in. You can if you want to, but I would highly recommend looking at those because those are ones that are also on the test. So, on the back side, I already said on the podcast, on the back side, you could cross off the majority of the back except for, I think I said, well, the bottom ones, I think I already have it on there, but actually the bottoms you can cancel out. The ones that, the word problems are on the second sheet that I'll address. So really, just make sure you can plug in the inverse on that. But again, we've kind of looked at that already.
So you don't
Moving forward.
27 to 26.
Correct. So from 27 to to 36, you could cross it out. I think, check me on this, ask me in class, but I think maybe there might be a calculator problem where you have to plug in the inverse, sine inverse of 0.345. So just knowing how to do that on my calculator. And if you don't know, we can look at that in class, all right? Awesome. Do you have any other ones? I'm kind of highlighting here, just kind of making sure we're going through. 15? Oh, that was a good one. I actually had that down. Let's look at 15 here.
Yeah, those are the wording of this.
So the big thing, I think the biggest thing is the setup, okay? All of these. If you look at number 15, if you look on the second page that I just gave y'all, I would highlight 43, 44, those few. I would even put 37 and 38 in the same category. All of those, it's all about the setup. If you can't set it up, there's very little opportunity to get that completely right. So let's talk through this real quick. 3-7, what quadrant is that in?
3-7.
3-7. If I just graph that point, where would that be at? First one. Very good. Good, Morgan. So we're gonna put this here. That's an awful line, but you get the idea. So we know that there's a triangle here, right? Now I'm gonna highlight it so you don't get confused there. This right here is the triangle. A couple things on that. Number one, it's always connected to my x-axis. Number one. Number two, it always connects to my vertex on my origin. Okay, that's important because when I come to something like this, I know that theta will end up being right in this area right here. Theta is always connected to my origin. Let's see if I another color. I know it doesn't work, but you get the idea. It's right here. Theta is at this location. Second thing is you know now what the adjacent and opposite side are, right? What would be this side right here? Good, because it went 3 to the right, right? So 3-7 means 3 to the right. And what about the 7? It's going up, right? Very good. Now, if 3's to the right, 7's up, and we know we're focusing on theta, the next thing that we're kind of going in on is what is cosine of theta? Well, with cosine of theta, this is where you need to know this. Cosines, there's two things with this. Number one, we know it relates to x. And number two, we know it is adjacent over hypotenuse, right? Those are the two things you need to know. I'm not going to give those to you. Which one of these would I use? Would I use the x or the adjacent over hypotenuse? Good. Is anyone confused on that? Why that's the case?
Hypotenuse.
Say it again.
I thought hypotenuse was where nothing is.
Yeah, you're right. We got to solve for that.
Oh, okay.
We're going to get to that there in a second. But does everyone understand why we don't just use the x, why we use adjacent over hypotenuse? The reason why is, are we talking about the unit circle? No, I will specifically tell you, use the unit circle for this. Use the unit circle for this. And I will tell you, if you're ever confused on that, ask me on the test and I'll tell you, okay? So because of that, yes, cosine is related with x, but more or less right now we're adjacent over hypotenuse, okay? So what would be the x? How would I solve for that? Good. So right now I'm guessing that as I'm talking through this, y'all pretty much probably have a good idea of how to do this now. All right? I'm telling you, it's all in the setup. Okay? If you're at home or if you're in Sweden right now watching me live, all hundreds of thousands of you on YouTube watching me, you know that the big thing is the setup. You get the setup right, you're going to get the problem right. So when I solve for this, I got 58 equals x squared. I can square root this, and I don't think that I could take anything out of this radical in common. You know, anything that's a pair. Why would I? Because remember, it's equal to c squared, or in this case, x squared. So in order to get x by itself, you got to square root it. Okay? All right, so we've got this square root of 58 here. So what would be the cosine of theta? Good, 3 over root 58. We don't, go ahead. Yeah, where's the adjacent side? Yeah, 3 connected to my theta, right? Remember opposite over here, okay? The OH, opposite of, well, no, I didn't mean to say that. The opposite. I am on a YouTube saying that. It's, yeah, that school down south, all right? So what we have right now is the hypotenuse is here, the adjacent is here. So therefore, it's 3 over square root of 58. We multiply top and bottom by root 58. So we have 3 root 58 over 58. I hate the fact that this is live and I can't delete
They
this.
said like something bad.
Oh, they thought I swore or something?
I didn't know what you said.
I've done that on accident too. Not purposely, but it sounded like that. But 358 over 58. Are you good there? Are we good on that? Okay. I know. You did? What about that?
I emailed you last night. Trying to
Yeah, mine didn't let me.
It's like it's still saying the same error.
I'm gonna adjust that today. I'm gonna adjust that. Try. Have you tried today?
No.
Just try today. And if it still doesn't work, we'll work something out.
Okay.
Sound good?
Just give me another pile of pee.
Yeah.
Oh, that should be fun.
Yeah, I hear you on that one, man. See ya.
Okay.
All right. My apology there, YouTubers out there. Any other questions y'all have? Yep.
You knew where we had to find. It was on one of the things, but it's like you gave us two sides and you had to find an angle, and then you gave us an angle on one side and we had to find something.
I thought you did yesterday the S.
No. It was like.
Yeah, like a word problem you're saying, right?
So 12?
12 would be, ooh, that's
Is that
a
what
good
you're
one.
talking
That's
about?
exactly
Yeah.
right. 12, and if you want another practice, look at 37 too. 12 and
The
37. is a good
setup
one.
on these, I'm just confused.
Yeah, the big thing is just understanding what it's saying, okay? And also, if you don't know, if you're like, oh my gosh, don't leave it blank, you know? And at home, if you're watching this, don't leave it blank, do something. Because if you get it completely wrong and you solve for something wrong, at least I can look at it and say, oh, their setup was incorrect, but their whole process was awesome. You know what I mean? So that's the big thing. And a lot of times, you can gain back even like half credit for that, which is huge on a test like this. So first thing we know is we have the telephone pole, okay? And we have a wire connected to the telephone pole, right? All right, so here's the grass down here, okay? If a wire's connected to that, right? You think about it, where would it connect to? Yeah, just the top. And so it's going to go all the way down to the bottom, right? So we know that. We know this pole is 60 feet, right? And we know does it tell us what the wire is?
75.
75 feet, okay? This is where you got to be careful, okay? And I'll put just feet here just so you know. You got to be careful because I could tell you that, okay, from this pole, from where it connects to the ground to the base of it is 75 feet. So that means that you would put 75 on the bottom, right? So it's just be careful on it. There's also another problem that I saw where there's like a tower and then there's a shadow, right? There's a shadow that kind of comes out like this. The question was from the tip of the shadow to the top of the tower, what's that distance? Got me? Remember, a shadow's on the ground, right? So just be careful on that. I think a lot of people said, oh, the shadow's right here, right? Well, the shadow doesn't come. Does that make sense?
I would have thought that, yeah.
So just be careful. The shadow, like if you're walking, the shadow's on the ground, you're standing tall, then that's the triangle created. I don't know if that makes sense, but that's the idea there. I'm trying to think 30. Oh, yeah. So 37 is perfect on that. If you look at 37, that one's different, right? 45 would be actually the base of it because it's the shadow. That's the length of the shadow is 45 feet. But does that make sense? Are we good there? See the difference? Okay, perfect. So it's asking us on this one, what is the angle between a telephone pole and the wire? All right, what angle would I be solving for? We see the 90. Where would I go? Here
Yeah.
or here?
No, top.
Top, right? Because again, it's between the telephone pole and the wire, right? This wouldn't be between the telephone pole and the wire. A lot of people did this. Now you could solve using this one. That's fine. And then add 90, subtract from 180 to get that angle. That would work. Okay, that would work. But you don't have to. So if this is theta right here, let's talk through this. What would be the adjacent side? 60, good. What would be the opposite side?
That's it right there. Where you go.
Yep, because again, it's opposite from theta, right? And what would be the hypotenuse?
75.
Good, hypotenuse is 75. So based upon what we know, what would we use? Sine, cosine, or tangent? Cosine, excellent. Because we have adjacent and we have hypotenuse. So what I like to do is, for those of you who maybe have a struggle with this, write down cosine of theta equals adjacent over hypotenuse. I don't know what theta is. That's what I'm solving for. The adjacent side is 60. Good. And the hypotenuse side is 75. So how do I get theta by itself?
Would you do second theta?
Second,
I
you're
mean,
close.
second cosine.
Second cosine, perfect. And that's where the inverse comes into play, right here. What mode would I be in here? Degrees, because I want degrees out. Okay, I want degrees out, that's why. So anytime I'm using theta, or I'm trying to use inverse of theta, I want to make sure that what I'm trying to get out is my degrees, whatever it is in degrees. So I cancel, cosine inverse of 60 over 75. I don't have that answer with me. 37, and is it point something?
Or it was 36.86.
Yeah, let's do this. Let's round to the first decimal, 36.86, so it would be 36.9. And we'll say 36.9, it shouldn't be feet, 36.9 degrees should be the answer right there, okay? And that's, again, anytime I'm solving for an angle. Anytime I'm solving for an angle, and I said it like 10 times in class. Anytime I solve for an angle, I'm using inverse. So again, it's going to be a word problem, that type of thing, or it'll be one that I just say, hey, you do this. So anytime I'm getting an inverse, that's what I'm looking at there, kind of going forward off that.
I
Okay.
have a question on
Yes.
when you do the inverse of cosine. and
Yes.
You have problems sometimes where it has the x on top and then the number on the bottom, or the number on top and the x on bottom.
Yes.
Isn't it? I just get confused. When do you multiply those and when do you divide those? Like, isn't
Great
one
question.
rule like where it's on the top? I can't remember.
Great question. Before you get to that, Maddie, I'm going to just say one thing on this. Is cosine inverse the same as secant?
Yeah.
It's actually not.
No.
Okay? It's actually not. I just want to make sure. So if I say find the secant of, 0.1210, and I said use your calculator to do that, do not do cosine inverse there. Does that make sense? This is finding the angle. To use this, I would use 1 over cosine. That would be the same thing as secant.
Okay.
Does that make sense?
Yes.
Does that make sense there? So just be careful on that and going forward, okay? All right, so to answer your question, let me answer your question now. Let's look at number 38. Can we look at number 38? That one's perfect for that. This, what you were talking about. Because right at this point, what we're doing,
All right.
Is
have
we're
the angle,
solving-
but we don't have any other side.
correct. So right now, the picture gives it to us.
They give you like the
Yeah.
angle and then one side.
Right.
So we have 50 on the bottom and 32 degrees at the bottom right.
Which one's this one?
This is number 38. This one is the one, the extra one there. The one that kind of gives you some extra problems to look at going forward. So on 38, 32 degrees is that angle. 50 is kind of towards the bottom. We know that we're going to be looking at the opposite side. We're going to label that as x, okay? Because that's exactly what we're solving for. It's the distance across the lake, I believe is what it was saying, right?
Why would you not solve?
Yes, this one's across the lake now.
Yeah. Why would you not solve for?
Good question. So you see the picture, Pat, there's this guy standing over here, right? And the lake is kind of, it's maybe hard to see there,
Oh, okay.
but the lake's here, right? Okay?
Yeah.
So the distance across the lake, that's kind of where we're, like right here, this guy's like inland a little bit. So that's not the distance across the lake. Does that make sense? That would be correct, okay? So what we would be doing is we're trying to solve for x here, all right? What would that be, opposite, adjacent, or hypotenuse within that triangle? Opposite, good. And I always label it. You could do whatever you want. I like to label it because that helps. What about 50? Good. So Morgan, based on that, what would we use? What ratio would we use? Tangent, good. So what I like to do is tangent of theta equals opposite over adjacent. What goes in for theta?
32 degrees.
Good. What goes in for opposite?
Um,
X. What goes in for adjacent?
50.
50, good. And so how do I get that x by itself? Good. We're going to multiply it by 50. All right?
Okay, okay, that's what I was.
Can we
And then
switch
when it's
it?
on the bottom, you divide, correct? You divide by that first.
Yes. So you want me to give you a hint? Okay.
Yeah.
So 50 tangent of 32 is your answer, right? When you plug in, make sure it's in what mode?
Degrees.
Degree, because I'm putting in degrees. Now, be careful. This is a side note, okay? This is a side, not related to the problem at home, okay? If you're watching this at home, please do not get confused by this. So if I did this, what if they were flip-flopped, right? Separate.
Right.
If it was 50 over x, You want a quick hint? This is easy. Easy to remember. You can multiply by x, divide by tangent of 32. That's fair, okay? Or it might be easier to just remember. If I have a variable on bottom and they're both equal to each other, switch them. Just switch them. So I know that x is equal to 50 divided by tangent of 32.
Okay.
Does that make sense?
Yes.
So I just flip-flop them. When I flip-flop them, you're going to end up getting the correct answer there. Only when the variable is on bottom, okay? Only when the variable is on bottom there, all right? Do y'all have any other questions at all on that?
Not right now.
All right, right there at home, if you're watching this podcast, we did, I think, about 8 to 10 problems there. In class, if you need some more help, you could come on in, and we will look at more in class today. Other than that, I hope you have a fantastic day. We'll see y'all later. Bye now.